Now we will discuss one more concept, that is Nernst equation. What is a Nernst equation, sir? The quantitative relationship between concentration of the ions and electrode potential was given by Walter Nernst. Scientist name is Walter Nernst. It has been pointed out earlier that the tendency of metal try to lose electrons and the tendency of non-elements try to gaining or depending upon the concentration of ions in the solution. At the same time, the tendency lose or gain of electrons expressed in terms of electrode potential. The value of electrode potential changes with variation in the concentration. Simply, the standard reduction potential values, standard conditions, temperature is at 25 degrees Celsius or 298 Kelvin. Concentration is equal to 1 molar, pressure is equal to 1 atm. The electrode potential can be calculated by the standard conditions are called standard electrode potential. If the concentration is changes, is called non-standard conditions. The electrode potential can be calculated by the non-standard conditions by explained by the expression Nernst, the quantitative relationship between concentration of the ions and electrode potential. What is the statement of Nernst equation? The quantitative relationship between concentration of ions and electrode potential was explained by an equation is called Nernst equation. This Nernst equation is of electrode can be explained by various ways. The first way, for general electrode reaction, Mn plus gains electron to form M. Where M is a metal, there are two ways are there. How to write the equation here? Electrode potential of M, N plus by M is equal to standard M of the cell, M N plus by M plus RT by NF Ln concentration of reactant by concentration of product. This is one way. Or if you take a product, already you know arrow mark left side substances are called reactant, right side substance products. Okay, one more way, electrode potential of M N plus by M, standard electrode potential of M N plus by M minus RT by NF Ln concentration of MO by concentration of Mn plus ions, where R is a universal gas constant, T is absolute temperature, N number of electrons involved in the reduction, or simply number of electrons gained, where F is a Faraday's constant, 1 Faraday is equal to 96,500. coulombs, where M is a concentration of metal, Mn plus ion is a concentration of metal ion. Okay, this is information about Nernst equation. It is modified into small equation, that is where here Ln is nothing but here Ln is nothing but 2.303 LOG, R value 8.314 kilojoule per mole. 1 Faraday is equal to 96,500 coulombs. We can replace these values into this equation. Okay, we can get the value that is equal to here Mn plus by M is equal to standard EM of the cell plus 0.59 by N LOG, concentration of metal ion by concentration of metal. I hope it is clear. While using this equation, the following points must be kept in our mind. The first point is the concentration of metals or solids, pure solids, is equal to 1. The concentration of ionic species is expressed in the mole per liter. The concentration of gases expressed in terms of their respective partial pressure in the bar. Okay, this is information about how to write the Nernst equation of various equations. I hope it is clear. Next, Nernst equation for hydrogen electrodes. Nernst equation for hydrogen electrode. Hydrogen electrode is a reference electrode. Okay, what is the reaction involved here? 2H plus ion gains electron to form H2. That is the reduction. Gaining of electrons are called reduction. Case EM of the cell is equal to standard EM of the cell minus 2.303 RT by N F log of concentration of H2 by concentration of 2H plus ion whole square. Guess here E cell is equal to standard EM of the cell minus 0.59 by N log of concentration of H2. Already know 1 mole of any gases are expressed in partial pressure. Concentration of H whole square. The standard EM of the cell is equal to, for hydrogen is equal to 0 minus 0.59 by NF 1 mole by concentration of H plus ion whole square. That is equal to standard EM of the cell is equal to minus 0.59 by log of concentration of H plus ion power minus 2. Power minus 2. Now, by N. N means number of electrons are involved. How many electrons are involved in this reaction? 2 electrons are involved. That means gaining of 2 electrons. Okay, that's why here E cell is equal to log a power m is equal to m log a minus 0.59 by 2 into minus 2 into concentration of H plus ions. And also finally E cell is equal to 2 to cancel minus 0.059. Negative logarithm of H plus ion is called pH. Okay, this is oxidation potential of hydrogen electrode plus 0.059 pH. If you take reduction potential of hydrogen electrode is minus 0. If you take this is reduction potential of hydrogen electrode. If you take oxidation potential 0.059 pH plus means oxidation potential is always opposite sign. Oxidation potential is equal to minus reduction potential. I hope it is clear how to determine hydrogen electrode by using of Nernst equation. Relationship between Nernst equation and equilibrium constant Kc. Equilibrium constant Kc. Okay, actually for a cell, the net cell reaction involving in electrons. Okay, now I am taking one small example here. Small a moles of A reactant, small b moles of B reactant gives rise to small c moles of C, small d. This is one chemical reaction. By using of Nernst equation here, E cell is equal to standard EM of the cell minus 0.059, or if you take RT by NF, Ln concentration of C power C, D power small d, small a power A, capital A, B power, capital A power small a, capital B power B. At equilibrium, the cell cannot perform any useful work. So that the equilibrium, EM of the cell becomes 0. And also at equilibrium, the ratio between concentration of product and concentration of reactant is nothing but equilibrium constant. That means here, this is equal to, at equilibrium, E cell is equal to 0. Standard EM of the cell, okay, we can replace this values 0.059 by N LOG. This is called Kc. Or if you take normally not that value, if you take LOG Kc. Now what is the relationship between standard EM of the cell and this one? This part transposing that side 0.059 by N log Kc is equal to standard EM of the cell. Log Kc is equal to this part transposing that side. Standard EM of the cell into NO by 0.059. Log transposing that side, Kc is equal to 10 power N into standard EM of the cell by 0.059. This is the relationship between standard EM of the cell and as well as a equilibrium constant. I hope it is clear. And one more concept, last topic, relationship between Gibbs free energy and standard EM of the cell. Gibbs free energy. Gibbs free energy change. What is Gibbs free energy, sir? The amount of energy is available in a system to do useful work at a constant temperature and pressure. Simply the amount of energy is available in a system to do useful work at a constant temperature and pressure. In a galvanic cell, the chemical reaction takes place and electrical energy is produced. In a galvanic cell, does electrical work by transferring electric charge through an electric circuit, external circuit, when only infinite, that is very small current is drawn from the cell. The change of free energy is equal to the electric work. The change of energy is equal to useful electrical work, external electrical work. Okay, this electrical work, the following are possible. Delta G is a negative, positive or equal. This quantity of charge. Okay, what is electrical work, sir? W is equal to electrical work into EM of the cell. Cell EMF, standard electrode motive force. Okay, what is electrical work means here now? Charge into number of electron transfer. Simply standard EM of the cell. W is equal to charge means here Faraday. NF into standard EM of the cell. According to thermodynamic quantity, let us the electrochemical takes place galvanic cell, n moles of electrons are involved, and also this electrical work is done due to the change in its free energy. In thermodynamic quantity, delta W is equal to delta G negative sign. That means minus delta G is equal to NF standard EM of the cell. Delta G is equal to, or if you take just standard delta G naught is equal to minus NF standard EM of the cell. Okay, this is the relationship between Gibbs free energy change and standard EM of the cell. There are three cases are there. If the standard EM of the cell is a negative, then the standard Gibbs free energy changes value positive. Means here if it is negative, minus of minus plus. Okay, that's why if the delta G value is positive, means the EM of the cell should be negative. Delta G is positive means that is called non-spontaneous reaction. Then the reaction is called non-spontaneous reaction. If the standard EM of the cell is equal to positive, delta G naught is equal to negative, then the reaction is called spontaneous reaction. Spontaneous reaction. And finally, third case is there. If the standard EM of the cell is becomes equal to the 0, delta G value is equal to 0, then the reaction is called equilibrium reactions. Three cases are there. If the delta G naught value is, if the standard EM of the cell is a positive spontaneous reaction, delta G naught value is negative. The standard EM of the cell is negative, delta G is a positive non-spontaneous reaction. If the standard EM of the cell is 0, delta G value also 0, because that is the equilibrium reaction. Okay, this is information about Gibbs free energy change as well as a standard EM of the cell. Okay, what is the relationship between Gibbs free energy changes and as well as the equilibrium constant? Small one is there. That is delta G naught is equal to minus N of standard EM of the cell. Already you know this one. Okay, now what is the formula of standard EM of the cell? Standard EM of the cell is equal to 0.05, 2.303 RT by NF log case. Now I am replacing this equation here. Delta G naught is equal to minus NF into 2.303 RT by NF log Kc. NF gets cancelled. Delta G naught is equal to minus 2.303 RT log Kc. Thus one can obtain delta G naught from the value of equilibrium constant vice versa. That means this is standard Gibbs free energy change. This is the Kc. This is the relationship between equilibrium constant and Gibbs free energy change. I hope it is clear. Thank you.